Example 3 is a graphing calculator question from the AP exam. So we need a graphing tool to be able to solve this. You can't solve this algebraically without a graphing tool. So if we take a look at the functions, f is this exponential function here. So it's 1 plus x e to the x squared minus 2x, which is this blue function. And the g function is a polynomial function here. So note that this cannot be solved algebraically for zeros. So what the question is asking for is, we have these areas R and S that are bounded by these functions, and these regions are going to be where R is where the green is above the blue, and the S is where the blue is above the green. And so we need to find the sum of the areas R and S and show the integrals involved. Okay, so to be able to do this, we need to know the bounds. So the first thing we need to do is we need to actually solve for this intersection point here. So they've given you the intersection points of 0 and 2. So you're going to have to solve for the intersection point here. And when we solve for this, we get 1.0328. Okay, so if you're using the TI-83 calculator or 84 calculator, you want to do calc intersect to find that x coordinate. So that allows us then to establish the bounds of our integration. So if I want to find area R, which I'll just kind of shade in red here, area R is going to be the integral of the upper function, in this case is going to be the g function, minus the lower function, which will be the f function. And then we give it some width, and we're going to integrate from 0 to, and I'm just going to round this to 1.03. Okay, now when I do this on my calculator, I'm going to find the shade the area underneath the g function from 0 to 1.328. and then subtract the area from 0 under the f function from 0 to 1.0328. So when I do this, my calculations look like this. So the area under g is 3.1137. When I shade the area under the blue, which I'm going to subtract, the area under the blue function is going to be 2.1163. So the net area works out to be 0.9974. And depending on the accuracy of your decimals that you're using, you might be off by a little bit. So that's the integral to solve for the R. I'm going to then find the area here, this area S, which I'll do with blue. The area S is going to be the integral. I'm going to start at 1.03 and I'm going to end at 2. Now in this case, the f function is above, so I'm going to do f of x minus the lower function g of x dx. And so to find out that shaded area, what I'll do is I'll find the area under the f, which I calculate to be 2.9599, and then I'm going to find the area under the green function, which is g, and subtract that. So the area under the g function, when I do the shade that area, I get 1.9530, and again, you might be off by a little bit depending on the rounding that you use for your boundary points. So when I subtract those, I get 1.00 about. Okay, and so my R plus S, the area of R and S, that calculates to an area of about 2.00 units squared.